So we're refining our position vector skills, and we're going to start with example 4. So I've given you a position vector. I've written y. I don't know why I've written y. I need to change that to RT. Should have done that before I started the video, really. Anyway, RT equals 3ti plus minus 5t squared plus 1j. What type of motion is this? It's parabolic motion, so it's a form of projectile motion, the motion we get under the influence of gravity. And here I've got also given a cue to use an arrow to indicate the direction of motion as well. So I want to sketch the path of the motion and describe the motion of this function. There are 2 ways we could do it. Can anybody identify either of those ways? Well, how are we going to sketch it though? So find coordinates. Yep, we could find sets of coordinates. We did that in the first example yesterday. What's the second option? Determine the Cartesian function, so y as a function of x. Let's start with the second plan, but then we might add some coordinates to help us along the way as well. That's going to move the motion. So let me just try this again. Okay, so I'm going to start by saying x is equal to 3t, which means that t is equal to x over 3. That's my equation 1, and it comes from that point there, x being the I position. And then y is equal to negative 5t squared plus 1, brackets around there, which means that y is equal to negative 5x over 3 squared plus 1. And I can simplify this to give me negative 5x squared over 9 minus 1. And that's the quadratic form of our motion. So we now have, so this is equation number 2 with the substitution. We now have our Cartesian form, which we can sketch. So if I wanted to sketch this, hopefully you can see it's not too bad to sketch, but it's a little bit problematic because I don't know a lot about the position, and there's a couple of domain issues which we'll get to. But I've got a minus 1. So if x is 0, it starts at minus 1. It's there. And it's also motion that's been flipped upside down. So it looks a bit like this. That's the parabola. I haven't really designated a very clear and effective way of representing the steepness or the dilation of this parabola, but at the moment that's the general shape of it. To refine this though, this is where I'd start to talk about, okay, where does the motion actually start on this parabolic curve? So I'm going to rub that out, change my graph now that I've done a bit of planning, and have a look at where it starts and try and be a bit more accurate. So I've got, there's my motion there, and I'm going to draw the whole graph in light blue. But then what I'm going to do is start plotting some points for particular time values, which will allow me to put an arrow. I'll get a starting point and I'll get a direction of motion. All I really need is time equals 0 and time equals 1, and that will give me enough information. So at t equals 0, RT is equal to 0i minus 1j. Put 0 into that function, and I've got that. So at t equals 0, I've got this point here. This is my point, t equals 0. At t equals 1, I've got RT equals 3 times 1 is 3, so 3i. And then 5 times 1 squared is 5, plus 1 is 6, but it's minus, so it's minus 6j. So 3 minus 6, wherever that is, let's say it's down here. This is t equals 1. And so my actual motion starts here and moves along the parabola in that direction. And this bit is not part of the situation. Part of the Cartesian function, but it's not part of the projectile motion, because the projectile motion is defined as starting at t equals 0. So now this is the path of the object, whatever it is, and I've got an arrow indicating which way it goes. I've got the starting point clearly indicated. Are there any questions on that? We've now got a lot of information from that one position vector. We've got a lot of information about what's happening. Okay. Example 5. Y equals cos ti minus sin tj. What type model is this? Circular motion, and because the cos and the sine have got the same coefficient, then it's an equivalent circular. It's just a circle, it's not an ellipse. Sketch the path of motion and describe the motion of this function. So firstly, I know it's circular motion, but I'm going to develop it first because I should do this every time. X equals cos t, which leads to x squared equals cos squared t. Y equals sine, or y equals negative sine t, which means that y squared equals sine squared t. When I square a negative, I get a positive. And therefore, x squared plus y squared equals cos squared t plus sine squared t, which equals 1. X squared plus y squared equals 1. And that, of course, gives me, like we said, this circular function going through those 4 main points. I'll do in light blue again, just to make sure that I get it right. But if it's going in a circle, obviously, eventually it's going to pass through every point. So it's not like the previous question where I cut off half the parabola. This time, it will go back to the start and then continue. What I do need to work out is what the start is, where it starts. So at t equals 0, oh, that shouldn't say y again. I don't know why I've done that. RT, at t equals 0, RT or R0 is equal to cos of 0, which is 1, minus sine of 0, which is 0. So I get 1i plus, just 1i, which is here. So that's my start. And in terms of the direction of motion, I now put in the time a little bit after that. The full period of these two is 2 pi. So I can put in time equals 1, and that'll take me part the way around this way or part the way around that way. So what's cos of 1? Is that positive or negative? Oh, sorry, you're right. I was thinking because cos starts at a peak, I think that's what it was. Okay, there's my start. What's cos of 1? Is it positive or negative? Positive, so at t equals 1, I could evaluate this, but r of 1 is equal to positive I. What's sine of 1? Positive or negative? It's positive, but negative sine of 1 therefore is negative, so I'll accept either answer here. Plus a negative j. So a positive I, negative j is somewhere in here, so the direction of motion is that way. So the object starts at this point and moves around the circle in the clockwise direction. After 2 pi, it will be back at the start. So it's got a period of 2 pi. Happy? That just takes a bit of investigation. So the statement at the start of this lesson was, you need to be able to get as much information about the motion of an object as quickly as you can to be able to sketch that motion and describe it. So the description, which you may write as a paragraph, but I'll just dot point it, will be it's circular and clockwise. And you might also put in the circular radius is 1. Whatever the contextual units are. Reduce.